little bit of a different startup here. I'm playing chess, and I just beat this guy in 12 moves, so I'm pretty psyched. Similar to this upcoming section, and just like chess, this kind of has a lot to it in the sense that you have to think out all of your moves before you move further. This section does get a little wordy, and I think falling back on a few core uh, steps is really going to help you through this section. So this is a little bit of a start. I beat this guy in 12 moves, and he just resigned. I mean, he had a chance, but here I was going to take his king, and it would have been pretty difficult for him to come back from that. Um, so a little bit different of a start. But anyway, so we're looking at a wordy section that we're gonna instill a few main ideas for. So as we move through this section, it's going to be using these problem-solving strategies that I think are helpful for any type of word problem, whether in a math course or in physics, where of course we're going to be reading the problem. I'm also going to highlight here that we're going to highlight what we know and don't know, which kind of ties into identifying what's important. But of course, reading the problem is crucial. If we don't understand the problem or what we're reading, then we can always go back and reread it. We'll identify all of the information given in the word problem, so highlighting accordingly, or maybe as we go along, circling what we need. We might draw a picture if necessary. We'll state what we want. We'll create an equation, and then we'll solve accordingly. So as we see here, all of the math that as far as an equation or solving is going to be in the last two steps. And I think if you start to think through problems in this mindset, word problems become naturally easier and easier. Of course, there is a lot of wordiness, and there might be some hidden agendas as far as what's important and not important, but you can take this problem solving set or skill set and take it further. So as we move through this section, I'll always fall back on these if I get stuck. So with the first problem, they have us talking about an online music club selling compact discs for $13.95. Each has $1.95 shipping and handling per order. If Maria's total bill was $85.65, how many compact discs did Maria purchase? So I feel pretty confident that I understand everything that's going on here. Going off of the I, identifying all the information given in the word problem, listing that separately, circling what we need to solve. So I'm going to circle the numbers, and I'm going to underline what they represent. So I know that this is the number or the pricing for a compact disc. I know that they have shipping, which is correlating with this 195. Handling's part of that also. And this is per order, so I think that's pretty important. And the total bill here, I always think the total of anything is crucial in a word problem because chances are you're going to have to fall back on that and keep it in the back of your head. So this total is important. So I'll use blue for that. So let's see. If we go back, we've identified what we need. We've circled what we need. As far as drawing a picture, I don't think we need to do one really here. So I guess we could draw a little bit. We could say that for each CD, let's say that the graphic on this CD is just $13.95. I think that's good. Little CD, $13.95. So although this picture is pretty extra, I know that if I keep adding additional CDs, kind of an outdated music format, since most of the music's on Spotify or YouTube now, each of these CDs is going to be $13.95. So as far as the goals, we should be expressing this in our own words. And if we look back at the problem, we're being asked to find how many of these discs did Maria purchase. If we're going off of the visual, pretty much how many of these do we need to have until we get to 85.65, keeping in mind that there's only one order of shipping. So there's the shipping part, which is $195, and there's only one of these, so I'm just going to leave one. But eventually we want to keep adding these up until we get to 85.65. As far as the equation goes, let's try to math this out. Well, we know that our total bill is going to add up to $85.65. And there's the one-time fee for shipping and handling. So I'll use the S and H for that. So shipping and handling, that's only a one-time fee. But then we add on the number of disks. So let's note that with disks. Let's call it the number of disks because we don't quite know that. And this is going to bring up the price depending on the price for each disk, which is $13.95. If this problem seems easy and pretty extra, you can run through it, but I'm going to follow through with the steps because I think those are helpful. If we solve, or we have the equation set up, we've used the realistic terms that they've given, and now we're solving. So the given information plugged into the equation. So I know that our total is $85.65. I know that shipping and handling is $195, and I'm adding that on with $13.95. And as far as the number of disks go, I'm going to use the variable D here for disks. So this is the number of disks. I probably should have labeled these variables earlier in the problem, but I'm doing it now. So solving this, getting rid of that 195, that's a good rule of thumb. So if I take 85.65, I'm deducting 1.95. I then am left with 83.7. And this equals that 13.95 multiplying with the number of disks. If I then divide, oh, let's get the answer back in there. So I'm dividing by 13.95. D is going to represent 6. But what does this represent? What are our units? I think this is an important thing to fall back on, the units. Well, this is asking us how many compact discs did Maria purchase with this total bill. In this case, this would be 6 discs. And it makes sense because if we plug it back in, or even if we were to continue this pattern of adding $13.95, $13.95, $13.95, $13.95 6 times, with that one-time shipping and handling fee, it would get us back to that $13.95. For the other problems, I'll give you a moment to try those out. You can sketch them out, you can write them out, take this time to give them a shot. This is a repeat problem, so you don't have to do that one. For the scale, you should be saying something along the lines of 1/50 for miles should be equal to 4.2 centimeters over the distance. Eventually, you have your distance equals 50 times 4.2. So the distance in miles, if this is scaled accordingly, which is definitely a thing if you used Google Maps before. So 210 miles. The next problem has a little bit of a scenario with a price drop. So we're finding the percent of the decrease. We know that in earlier years, 1995, that was before most of you were born. Well, that's before all of you were born. That's wild. We know that that was $1,299, but it was then multiplied by some percentage. Let's call that the percentage P. And that was then equal to 499. So we're being asked to find the percent of the decrease. So remember back when we looked at these problems, we had to find P. So if we divide both sides, 499 dividing by 1299. That gets us here. But then to find the actual percent decrease, if we take the difference of 1 and that, this is going to be the percentage of the decrease. So this is approximately, so again, here we said that P was 0.384 approximately, but the percentage of the decrease was about 62. So about a 62% decrease, which sounds about right because as technology has gotten older and older, technology has also gotten a little bit less expensive because it's just used everywhere. So if you get stuck with any word problems in physics or in this course, of course, fall back on these, write them down. I think they're really helpful, keeping in mind that for the first problem, we read the problem, we reread it if we were stuck, identifying what's important from there, circling it so that we can easily look back at it, draw a picture if possible. Sometimes you won't be able to, so when you possible or if you need a visual, you can do that. Write down what you're looking for. Here we were looking for the number of disks, setting up the equation, solving the equation, which I think this is where the real math lies. I think the reasoning, and there is mathematical thinking with these first four, but as far as solving an equation and probably what most people consider a math step, that's only in the last two parts.